Hello and welcome to another one of these ADD videos. Today we're going to be talking about normal distributions. They might also be referred to as Gaussian. Some people, forgot the A, might say mound. Very rarely will you hear mound. Or normal distributions. These are all referring to the same type of pattern that you tend to see for all real live data. Something in which the pattern and variability looks like this. Okay, so most things in life, there's always a central average, and it tends to be that average is also the median. It's the first characteristic of a normal distribution, and that means that 50% of the data lies below and above this line. Alright. Now, this data applies for everything from height, right? There's going to be some people that are tall, some people that are short. Most people are right in the middle. Weight. There's some big people in this world, and some really skinny people, and most people are right in the middle. Let's see. Grades, whatever you can think of that is looked at on a large scale like that is going to exhibit this few people getting 100 or perfect score, close to perfect score, most few people doing very poorly. That somebody forgot that there was an exam that day, but most people right in the middle. Okay. Now, there is an empirical rule that will have its own video, but there are distributions, breakups of, or a breakup of distribution using standard deviation that has characteristic amounts of data associated with those little sections. Watch that video and what I just said will make sense, even though it's, I guess, 2:50 in the morning and I'm having trouble forming sentences. So let's see. The problem with normal distributions is that you see how height is measured from 0 to 6 feet, 7 feet, weight 0 to 1,000 pounds, grades 0 to 100. All these things have such different scales and units that there needs to be a way to standardize it. And the way you standardize it is you use this z-score formula. And this is for one data point. And there's one for multiple data points. That becomes the mean now for multiple data points. And I'll be doing an example for both of those. And sigma sub n is just the sigma, or the square root of n. This is what that equals. Some books you just plug that in directly, others just have that plugged in. Alright? So what the concept is you will use your raw score to find a z-score. And then you will convert that z-score to a p-value. Now, I recommend that you get a complete table instead of one of those that go from 0 to roughly 3.5 for z-scores, and then the top part of your z-score column is just the last digit of your z-score. So like for this one, that would be 0.01, and this would be 0.01. So here, that would be a z-score of 3.51 where they net up. And inside the table you have what are called p-values, or proportions of the data that lie below your z-score that you just checked. In other words, you're below your raw score. And then usually we can use this to, if we're doing hypothesis testing, to make a conclusion. But usually for right now, all we need to know is, how to find a probability that's less than number, and that's, or the proportion that's less than. That's going to be the table value. And then if it's greater than or equal to a number, it's 1 minus the table value. And then there's in between two numbers. That one's a little bit more complicated. Okay, so for the, you got to do just 2 different problems. And these are all for the p-values after you found your z-score, right? So you're going to do first x is equal, greater than or equal to the number. Actually, let's write it over here. I have an eraser. I'm not using it. And x is less than or equal to a number. And you will do both of those, and then you will take the difference between those two. And there will be an example video for each one of those. Alright? So make sure you check them out. That's the basic concept for a normal distribution. There is also the empirical rule that I would like you to check out in addition to this video for concept video. Alright? But practice, practice, practice. Thank you and have a nice day.